How to write the equation for the electrochemical cell when given the standard electrode potentials, which are also called standard reduction potentials. Stay tuned. We are going to use KCSE Chemistry Paper 2 for the year 2024. Of course, our question of interest is number 4, Part A, Roman 3. Question 4 read that Table 2 shows standard reduction potential for given half cells. So the table is here with a total of 6 half cell reactions together with the associated E0 values. So part A demanded the candidate to draw a label diagram for an electrochemical cell using half cells 2 and 3. I want you to take note of our half cells. We have half cell 2 that involves reduction of cadmium ions to cadmium. And we have half cell number 3 where aluminum ions are being reduced to aluminum. In this video, our interest is writing the equation for the electrochemical cell that is made when the two half cells are linked together. We want to give you the stepwise procedure that a candidate needs to follow to get the equation correct. The first step is to consider the two half cells that have been given in the question. So our work at this point is simply to copy the two equations or the two half cells from our table. So the first one, we have cadmium ions, aqueous, accepting 2 moles of electrons to form cadmium atoms in solid state. Then, together with this, we have cell 3 that involves reduction of aluminum ions through acceptance of 3 moles of electrons to form aluminum solid. So these are going to be our two equations that we shall look at as we go through the procedure. Now, for step 2, we are supposed to identify the cell that undergoes oxidation. Why we are doing so is they are all presumed to have undergone reduction. And that's why the E0 values are also called standard reduction potentials. So our first half cell has accepted 2 moles of electrons. The second one has accepted 3 moles of electrons. In class, we told you that acceptance of electrons is reduction. But when you connect these two half cells, one must undergo oxidation and therefore will form our anode, as the other one undergoes reduction and remains the cathode. So, what do we do to identify this half cell that has undergone oxidation? We may need the E0 values. So for cadmium, from the table, the E0 value has been given as negative 0.40, and that of aluminum has been given as negative 1.66. So what a candidate needs to do is to consider these two values, and we follow a simple rule that the one that has the most positive E0 value, that is cadmium. Of the two, don't forget, negative 0.40 is more positive than negative 1.66. So this one will undergo reduction because it has a more positive E0 value. So that means that our half cell that has undergone oxidation is aluminium. So we are going to reverse it as follows. We start from the right hand side that has aluminium solid, and then we move to the left, giving aluminium ions and 3 moles of electrons. Remember, as you reverse this, even the E0 value now will change to positive 1.66. The other half cell will leave the way it is, and therefore I have cadmium ions accepting 2 moles of electrons to give cadmium. Of course, the value will remain as negative 0.40. Up to that point, I believe you have followed on what to do in order to identify the half cell that has undergone oxidation. Dear learner, we now proceed to our step 3, and what we are required to do is simple: balancing the number of moles of electrons in the two equations. So if we get back, equation 1 involves 3 moles of electrons, while equation 2 involves only 2 moles. So we need to balance them by multiplying equation 1 by 2 and multiplying equation 2 by 3. Let's go ahead and do so. So if I multiply equation 1 by 2, I'll now have 2 moles of aluminium solid, losing 6 moles of electrons to give 3 moles of aluminium, there'll be 2 moles of aluminium ions and 6 moles of electrons. Of course, the E0 value doesn't change. Then for my cell 2, having multiplied it by 3, I will now have 3 moles of cadmium ions, accepting a total of 6 moles of electrons to give 3 moles of cadmium. So this way, I have balanced the number of moles of the two equations. So what remains is now writing the overall equation. And before we do so, let's have a look at step 4. Step 4 is telling us to write the overall equation. We simply sum up the two. But before we do so, we now have to cancel out the electrons. So the 6 moles of electrons here will cancel out the 6 moles of electrons on the other side. And now the final thing that we do is to sum the two equations up. And therefore, on the left hand side, I will have 2 moles of aluminium solid reacting with 3 moles of cadmium ions, aqueous. Then on the right, I will now have 2 moles of aluminium ions together with 3 moles of cadmium solid. So this now becomes the overall equation for the electrochemical cell. And that is what the examiner expected of us in question number 4, part A, Roman 3. Thank you for keeping us company up to this far, and we urge you to keep it right here for more of such.